Hello, my name is William Rock, and I am an applications engineer at Headwall Photonics. And today I'm going to introduce you to our AgView software product. AgView is a software tool that allows users to easily extract useful agricultural indices from hyperspectral data. It allows the user to extract an RGB image and 6 common agricultural indices. There's the RGB image, the red edge ratio, NDVI, EVI, PRI, WBI, and mCarry. AgView will automatically do the radiance conversion, the reflectance conversion, and the orthorectification of a raw VNIR data set. It will then produce the 6 agricultural indices and the RGB image as orthorectified data cubes, and it will provide an output file that gives an overview of the results and a brief interpretation of all of the agricultural indices. Since AgView is automating much of the processing chain, all of the necessary files need to be in the proper locations for the program to access them. This includes the radiometric calibration data folder. So whatever computer system has the sensor installed on it needs to be used because the radiometric calibration data is necessary. The ortho.ini file needs to be in the same folder as all of the raw data. A digital elevation model needs to exist in the DEM folder, and I will show you the location of that shortly. And a scene white reference needs to also be in the data folder that was generated from a radiance data cube. The digital elevation model should be put in the DEM folder, which, if you have done the standard installation of Headwall software, can be found in C, Headwall, DEM. And for the data set that I'm going to analyze today, I have created a LiDAR DEM in the GeoTIFF format, and it is called LiDAR HSI mean. So it is a LiDAR DEM that was created using the mean method in Headwall's LiDAR tools. This is the screen that appears when AgView opens. It allows the user to navigate to the folder where the data resides. So I'm going to go back to that same folder. And in this case, AgView has automatically found the dark reference, but it allows the user to select a different dark reference if it did not select the correct one. But we can see here that it did go into my dark folder and select the proper dark reference. Now, all that needs to be done is to click Start. If some of the ancillary files are missing, errors will be reported down here as AgView is running. Otherwise, it is time to just sit back, relax, and watch the processing go. Now that the processing is complete, we can take a look at the results. So if we pull up the folder that contained all of our raw data, we can scroll through and quickly see that where before there was only raw data cubes, now there are data cubes with AG and RD appended to them, and AG, RD, RF appended to them, and AG, RD, RF, IGM. So those are the radiance data cubes, reflectance data cubes, and IGM data cubes generated from AgView with the AG in there as well. The radiance and reflectance data cubes are, of course, different conversions of the raw data, and the IGM data cube gives latitude and longitude positions for all of the spatial pixels in the data cube, which is a result of the orthorectification process. The other thing that is in the data cube is this AgView output folder. Within the AgView output folder are several additional data cubes. First, there are two NV type data cubes in there. One is a multi-OR data cube, which contains all 36 bands that are used to generate all of the AgView indices. And if the user opens that, they can see a full multi-ortho stitched image of the scene. And so here I selected all the bands. You can see 36 are selected. Again, this is a small subset of the full 270 bands that are available from the Nano Hyperspec. But again, these are the subset of bands that are used by AgView. And here we have a data cube containing all of those bands. And if you pull up the spectral plot, you can see a rather bumpy looking spectrum because there are only 36 bands instead of 270 bands. The other NV type output is the AgView output, which is a data cube for each of the 6 agricultural indices and the RGB cube. So again, here are the red, green, and blue bands. And if we convert to grayscale mode, we can see a grayscale representation of each of the different agricultural indices. There are also PNG files of all of the images, both in GS for grayscale or in color. And any of those PNGs can also be opened using whatever image viewer you like. And finally, there's the index.html file, which is a synopsis of all of the indices, exactly how they are calculated, and a brief explanation to the utility of each of the agricultural indices that is generated by AgView, and also a color image of each of the indices appended to this report. And you can also see that within this HTML file is a link to overlay the indices onto Google Maps. So if that link is selected, the Google Maps image of where all the data was collected is pulled up, and all of the AgView indices are overlaid, and the user can select on the left side to display any of the AgView indices. And if you zoom out, you can see that this is just an overlay onto Google Maps. And this is a cornfield somewhere in Colorado. Of course, the Google Maps image does not exactly match the AgView image because it was certainly taken in a different season, which is why when you see me switching from one image to the next, the corn looks a bit different than it does in the data that we selected.